In this lecture set, we will be focusing on energy extraction, specifically with a focus on mining techniques and nuclear energy. So your standard for today is Essential Understanding 5B.6, which talks about how human populations must design systems to obtain and refine mineral resources to support the needs of a growing population. Throughout this lecture set, we will talk about minerals, identify types of minerals that we can obtain through mining, compare and contrast different types of mining, describe different methods of mining resources, including the environmental and health hazards, and explain laws that regulate mining and mitigate environmental impacts, and discuss the parts of a nuclear plant and how it functions. So when we talk about the major types of energy that we extract, we tend to break them down into three basic categories. So the first thing is a desired material. So this is something that we want and that it's useful for us. We break this down into three different categories: metallics, non-metallics, and energy resources. When we talk about a mineral is any material that is naturally occurring and has chemical components or inorganic compounds that exist as a solid. So a mineral is naturally occurring, inorganic, exists as a solid. So we have metallic minerals, for example, gold or aluminum. Non-metallic minerals, salt, and energy resources, for example, coal, petroleum, and nuclear fuel. So the major types of energy that we extract here, these are the most common ones that we're going to go after. So the first most common is coal. Coal is collected through a mining process, and there are several types of coal. They begin with the least valuable, which is known as peat, which is a carbon-rich soil that you can find in a swamp or a bog, all the way up to the most valuable being anthracitic coal, which is very carbon dense and is found in mountainous regions or areas of ancient forests. When we talk about coal reserves, we're talking about concentrated, known stores that are easy to get to and are economically viable. Coal stores are most commonly found in the United States and in Russia. The second most common thing that we extract through the energy extraction process is petroleum. There are several types of petroleum. The most common is what we know as crude oil. That is what petroleum is known as soon as it is extracted. It will go through a refining process to produce petroleum-based products such as gasoline and the components that are used in plastics. Petroleum-based products can be gathered from other sources, specifically shale rock and tar sands, both of which are carbon-rich. And those are used to go through a refining process, and they produce alternatives to petroleum. The major concentrated reserves of petroleum are found in Middle Eastern countries. The third is natural gas. Natural gas is collected through the process of hydraulic fracturing, also known as fracking. And in this case, pressurized water is pumped into shale bedrock, the rock cracks, and releases the stored natural gas. The most concentrated natural gas reserves are found in the United States. The last thing that we're going to extract through mining is a mineral. We have defined a mineral as any naturally occurring chemical element or inorganic compound that exists as a solid. So we extract it through the process of mining. An ore is a rock that contains a large concentration of a desired mineral. And when we talk about ores, we categorize them as being high grade, meaning they contain large concentrations of that particular mineral, and low grade, meaning they have a smaller concentration. We lump nuclear material in with the minerals because that is what it is. Most common is uranium, and concentrated reserves of uranium are found in Australia. So there are several ways in which we extract minerals and coal for use. The most common way is through surface mining. Surface mining seeks to gain access to minerals or resources that are found near the Earth's surface. So there are four major types of surface mining. The first one is the open pit mine. So the open pit mine is one in which layers are removed going down in a concentric circle to the bottom of a pit where the resources are concentrated. So that's typically like an open pit, literally, that you're going to find the resources at the bottom. You also have an area strip, which is typically the most common one that you're going to see. And that is where specific areas of topsoil and other materials are removed until the desired material is exhausted. Once that desired material is exhausted, you move to the next area and then you remove it. You move to the next area, you remove it. The material that is removed is called overburden. And this is typically stuff that's topsoil, rocks, materials that are not really desired. The third is the contour strip mine. So the contour strip mine is very similar to the area strip mine, except it is moving up the side of a mountain. So you remove one strip on the lower portion, you move up and you do another strip on the next portion. And the material that is removed here is typically tossed over the edge of the level that's being mined. And that forms this very highly erodible mound that is known as a high wall. The last is what is called mountaintop removal, and that is where the entire top of a mountain is removed, typically using large machinery or high explosives. This is the most common form of mining in the Appalachian coal fields, where upwards of 500 mountaintops have been removed. So those are the types of surface mining. The last type of mining is called subsurface mining, and this is what most people think of when they think of a mine. So shafts are built into the ground, either vertically or diagonally, and they reach a vein of a mineral. The shafts are often supported and reinforced with materials and beams, but they are known to collapse. Subsurface mines often leave miners with lung disease from prolonged exposure to mineral dusts and gases. And surface mining, although it takes up much less surface area, tends to cause much more damage because of this thing called subsidence. And subsidence is when the ground on top of the mine collapses due to a lack of structural support. So there are two major laws that we have right now that regulate energy extraction and mining. And this is largely because of the potential environmental and health impacts. The first is the Mineral Leasing Act, which authorizes the government to lease public land for developing domestic deposits of coal, petroleum, natural gas, and other hydrocarbons. So this law is designed to encourage use of domestic energy sources. The second is the Surface Mining Control and Reclamation Act, which establishes a program that regulates surface mining and requires reclamation activities to be done after the mine is emptied. One of the things that this law does is it tries to reduce the problems that come in after the mine is finished. It tries to remediate the area by requiring the filling in of an open pit, the coverage of an area mine, the planting of trees, and mitigating activities to reduce the problem of acid drainage. And this is when water infiltrates a mine, carries through the acidic salts or the acidic compounds from the mining process, and carries those into nearby bodies of water. So the Surface Mining Control and Reclamation Act is really there to require mining companies to fix the damage that they cause as they are extracting this resource. So the last thing we want to talk about is a nuclear plant and how does it work. So the purpose of a nuclear power plant is to use a material that is capable of undergoing radioactive decay to produce heat. That heat is used to boil water to run a turbine. While there are many types of nuclear power plants, most of which use plutonium or uranium as their fuel source, there are two that are more common, and those are the two that we're going to talk about. The first one is a boiling water reactor. In this case, the reactor simply uses the reaction in the nuclear power plant to produce boiling water, whose steam will run the power plant. The second is a pressurized boiling water reactor. And these reactors pressurize the steam as it leaves the boiler, uses it to move the turbine much faster. Regardless of what kind of nuclear power plant you have, the parts are similar across the board. So this diagram really shows you the main parts of what a nuclear power plant is, what the parts do. So you have the containment structure at A, which contains everything. B, you have the control rods, which are located near the actual reactor. What the control rods do, they tend to be some kind of carbon-based graphite, and what they do is they can be lowered or raised to either slow down the reaction or allow it to move faster. So you have the steam generator, in which the heat that is produced in the reactor is carried through and boils the water. The steam line, which carries that steam into the next area, where you would find G and H. Specifically, H is the turbine, G is the generator, which is connected to an outside power line. You also have pumps that move water from a source up through the tank and move it into the reactor. And then lastly, you have the cooling tower, which is used to cool that water before it is released out into the ecosystem or before it is returned back into circulation. The cooling tower releases a lot of water vapor, very little carbon dioxide. Water vapor is the big one. So make sure that you can go back through these goals. You can identify and describe all of the things that are asked of you. And we will move on to the next one, dealing with public land.